we will view the effect of a pulp density change on the feed to the cyclone. When I click on number 9, pulp density changes, the exercise says that the plant is adding fluctuating flows of water to the sump feeding the cyclone. This is common to control the sump level. However, when this happens, there will be a fluctuating cyclone feed pulp density. This will cause some instability in cyclone pressure as well as your final product size. In the exercise, we will aim to find the cyclone setting that will work best for a range of feed densities between 55 and 65% solids. So when I click on the cyclone, I am currently feeding 60% solids feed to the cyclone. So let's simulate a 55% solids feed. After doing a simulation, I can see that the cyclone is still blue, which means that the cyclone is still within acceptable parameters. However, I can see in the underflow that the percent solids is quite low. This is to be expected with such a dilute feed to the cyclone. The pressure is reasonable at 78 kilopascal, and the recirculating load is 320%, which is also reasonable. So let's look at the upper extreme of the percent solids on the feed. So if I'm operating at 65% solids, I will have a problem in my cyclone at this operation. So when I'm adding less water to the feed, my recirculating load is too high, 387%. So in the advice, it says that the recirculating load is too high, and this will cause some problems. Typically, if you have such a high recirculating load, it is possible that the flow through the bore mill will be too high, in which case some of the balls in the bore mill will be ejected. So in the advice, we recommend that you reduce the apex size or increase the vortex finder size. It is much easier to reduce the apex size, so we will try that in the next simulation. If I reduce the size to 0.21, and I do my simulation, I can see that the cyclone has turned blue. That's a very reasonable percent solids on the underflow. The overflow percent solids is a bit high, but this is expected with this type of operation. The cyclone pressure is reasonable and the recirculating load is in a good range. But I want this condition to work for the full range of densities. So if I click on the cyclone again and try at 55% solids, I want this scenario to work as well. So after simulating at 55% solids, my cyclone operation will be efficient. You will see that the recirculating load will go up, the pressure will increase, but we will be within reasonable ranges of operation. So by reducing the spigot size, in this case, we would be able to deal with a large fluctuation in the cyclone feed density.